That's Triton. You want to hear about Triton?
Yes.
Okay, awesome. So, I have a disclaimer. Don't ask me about Pluto. At the question section, don't do it.
Now I'm gonna.
Don't do it. I'll be sad.
I thought we were gonna have a different period of time to watch you guys debate.
No.
Not today,
There
Satan.
may be.
Not
or may
today,
not
Satan.
be
Don't ask me about, you can ask me about Pluto, just don't ask about this.
I didn't say anything.
You said something. So, here's some basic stuff about Triton. Triton's really interesting. It's Neptune's largest moon. It's Neptune's only large moon. If you consider like the Galilean moons, Titan, whatever Uranus has going on with some of it. So it counts for most of the mass of Neptune's moons. I couldn't find an exact figure, but it's something like 99.5% of all the mass. I couldn't find an exact figure in literature, so don't quote me on that, but it's most of it. Its second largest moon is very small. It's also the only gravitationally rounded moon, and it's also the only retrograde moon that does this, that is gravitationally rounded, it's actually the largest one that does it, because Nereid is the second largest retrograde moon, and it's way smaller. It's also got a really high albedo. It's kind of blinding the camera there in this image. It's totally locked with Neptune. That's not really unusual for moons that are really close. But it has a weird orbital inclination. It kind of orbits, if Neptune's here, it kind of is like this. So the poles will be facing the sun at different times of the year. So it does have its own form of seasons in terms of which pole is getting more sunlight. It's the coldest known object in the solar system. It's a couple degrees colder than Pluto, probably because it has a really high albedo. It's also, weirdly enough, geologically active. So we don't know a lot about Triton because the only time we've ever seen it is through the Voyager mission, the pictures that it sent back. We only got pictures of the northern half of its surface, which I'll show you in a second. But based on what we saw, it's probably geologically active. So this is a map of Triton. As you can see, there's a big hole there where there shouldn't be. That's because Voyager, when it arrived at Neptune, Triton's southern half was facing the sun, so you weren't able to get photographs of its northern half at the time. So we don't know what it looks like. Generally have no idea. Just a little bit scary, but also a little bit exciting. I think we should find out what it looks like. Because it was a flyby, we didn't have enough time to do orbits and get pictures of the northern half, so we don't know a lot about it, which is, it makes it all the more interesting because what we do know is really weird. Because it has this. We have cantaloupe terrain. It's delicious. I hate cantaloupe, sorry. You guys can have it. So it's got this bizarre terrain. You can actually see it in the other slide. Oh, no, get back. Go back there. Thank you. You can see this cantaloupe terrain. It's kind of near the equator of the planet, which is really interesting. It seems like it continues into the northern half, but then again, we don't have data from there because it was a flyby. We didn't have enough time. So it's got this weird cantaloupe terrain. We don't know what causes it. There's a couple different theories. They think it might be cryovolcanic resurfacing, and there's some indication that it could be caused by cryovolcanism because we've also seen plumes, which I'll talk about in a second, and crustal overturn, which that is related to a subsurface ocean, which I'll also talk about in a second. The terrain looks like diapirs. Is that how you say it? Who knows? It does this. Dipper mentioned it briefly in his presentation about Europa, but they don't know if this is the case, and a couple of authors really don't like that idea. They say it's silly. But there's cantaloupe terrain, and it's really interesting. We don't really see it on any other body, but hey, actually, you can kind of see those same ridges that were on Europa on Triton. They're not as prominent, but they are there. That's fun. Triton has plumes. It has these weird plumes. We don't know what's in them. We don't know what causes them. we have photos of them. You can see it kind of where's that coming out of? Here. And it kind of extends like this. That's a 5-mile tall plume that is spreading across the planet. And they're dark, which is really weird. Because Triton itself is super bright, it has a really high albedo, so that indicates that, you know, it's a frozen surface, probably water ice, but why is this stuff dark? I don't know. It's probably nitrogen, it's probably got tholins mixed in. And these plumes probably don't last for very long. There are a couple images of Triton where you can see these dark spots coming out of holes. So they probably evaporate and move to different areas as the seasons change, or like are gravitationally lost in space. They don't know what drives these geysers or plumes. They say they're geysers, but they don't know, so they just call them plumes. So they don't know what causes the heating of that, because we just don't know a lot about Triton. So Triton may or may not have a subsurface ocean, depending on who you ask. And it's really funny, when I was reading papers about this, I kept getting like wildly different age estimates because no one's sure. I saw some people were like, yeah, it's a couple million years old, and then someone's like, it's a billion years old. And I'm like, okay, make up your mind. So Stern and McKinnon give a probable age of like 100 million years, which is really, really young. Venus is 500 million. I think Europa is probably a couple million. So that's very young, and that's kind of indicative that something weird is going on. There's not a lot of craters on Triton. You have to keep in mind, we only know what half a Triton looks like. So depending on what you think, there's either cryovolcanism going on, and that might be driven by heating in a subsurface ocean. We don't really know, but Triton has a lot of really weird geologic features that would make you think there's a subsurface ocean. And depending on what's in the ocean, it might have the basic building blocks for life, but who cares about that? We have more important things to talk about. More about that ocean. Triton's surface is really flat. Like it varies in topography by about like a kilometer, which for reference, the coast range is about that tall in terms of variation. So that kind of suggests that there's a liquid layer under Triton's ice surface that can't support, you know, mountains higher than a kilometer. The driving force behind keeping this ocean liquid might be gravitational interactions with Neptune. They aren't sure about this. They aren't sure if the ocean is there, so they aren't sure about a lot of this. We don't know a lot about Triton again. There's a really cool paper about this exactly from this remote sensing journal. It's like 40 pages long, but it's really neat. They did like a lot of cool stuff to make a pretty good argument that there's an ocean under Triton, a liquid ocean, which is really exciting. There aren't a lot of those. Well, I guess we're finding a lot now, but we don't know about a lot of them. Triton is fun, and the reason I decided to talk about it is because I'm obsessed with the Kuiper Belt for some weird reason. And it probably came from there. So its retrograde orbit, its weird tilt respective to Neptune's orbital plane, kind of suggests that it came from somewhere else, the Kuiper Belt. It has a lot of similarities with Pluto. It looks a little bit like Pluto. It's got the similar compositions, similar organic compounds on its surface, possible subsurface oceans. These guys think that Triton used to belong to a binary system, because binaries are actually pretty common in the Kuiper Belt. You've got Pluto, Charon, Haumea and its moons, yeah. So they think that a 3-body encounter with the Triton binary and a proto-Neptune could have ripped the system apart and pulled Triton into Neptune's orbit and then flung the other one into God knows where. Where is it? So depending on how this interaction took place, Triton's partner might still be out there somewhere. It might be one of the TNOs we know about. Here's Neptune's orbit. This is Sedna's orbit. This is 2012 VP113's orbit, and this is Leleakohanwa. Could be one of them. Could be any of them. Place your bets.
What is the blue line in the middle there?
Neptune. This is Neptune's orbit.
Okay.
Yeah. So these have massively elliptical orbits. If a gravitational interaction took place between a Triton binary and Neptune, it could have thrown one of those Kuiper Belt objects onto a massive orbit like this. We don't know. It's really interesting. The these guys have a fun theory about where Triton came from. They think it formed around Neptune. So this is a really interesting paper that they think that the NICE model that we talked about in class before had something to do with why Triton's orbit is so weird today. So they're basically saying, okay, Triton formed around Neptune, and that gravitational interactions with Uranus as they swap places is what caused it to go into a weird retrograde orbit. So they did a lot of simulations. I don't think the odds are very good, but I've done Pokemon shiny hunting with worse odds than that, so I don't know. Could be possible, could be anything. Could have happened. It's an interesting theory. I like it. I don't know if I believe it, but I like it. It doesn't really explain the compositional, I meant to write compositional similarities, I'm sorry. It doesn't explain, why Triton looks so similar to Kuiper Belt objects, but I don't know, they kind of formed in the same sort of region, maybe that's why. This is something we'd only know if we got, like, isotopic sampling of Triton. We just don't know a lot about it. There's a lot to learn, which is really exciting. This is the last little bit here. This guy, in 1936, wrote a really interesting paper just 5 years after Pluto was discovered. With a lot of complex calculations, he thought that Pluto could have been a satellite of Neptune alongside Triton, and its ejection out of Triton's satellite system is what triggered Triton's retrograde orbit. This sounds like crazy wackadoodle stuff, I know, but there's a couple really interesting observations here. He guessed this 40 years before he knew how big Pluto was. At the time, he thought it was the size of our Earth, which, I don't know, maybe we didn't know how big Triton was at that point. This is interesting to me because he only ever refers to it as Triton. So I don't know if this was unofficially used with astronomers at the time, but this was like 13 years before it was actually named Triton when we discovered Nereid. Because it was before that for 100 years. It was just called the satellite of Neptune. They were scared to name it. I don't know why. And he had this theory that these two planets were related, planets, moons, dwarf planets, whatever. These two objects were related 50 years before anyone else even thought anything else. So he speculated that Pluto took Karen in the divorce. So yeah, he's totally off the mark. We know that now, but some of the implications of his paper are really interesting today. He had some interesting ideas that a lot of them turned out to be wrong, but some of them were way ahead of their time. I think that's really cool. Yeah, almost 100-year-old paper, awesome. Here we go, yep.
Questions?
Hi, what's up? What's up?
Oh, so can you describe the cantaloupe terrain? Like what is the cantaloupe terrain?
It's ice. They don't know a lot about it. It just has this weird, like, it's really flat, but it just has these weird variations in it. It looks a little bit like some of the terrain in Europa with those ridges.
Yeah.
It's just very strange. They don't really understand. We barely know anything about Triton. It's kind of frustrating, honestly.
So it looked like, I don't know if you can go back to the image.
Oh, absolutely, yes.
But it looked in that image like the cantaloupe terrain. I mean, when I think of it, yeah, so it looks like a bunch of topographic highs and then kind of going back down to like some background.
Some flat.
Yeah.
And that's pretty compelling for a subsurface ocean, especially with these ridges present. But you don't really see exactly this anywhere else in the solar system. It's really just strange. I don't know. Weird stuff.
I think it's mostly depressions.
Okay.
The light's coming from the left there, and so most of the canal texture, not counting those ridge, is like depressions, and
Yeah, that seems to be the case.
They're like one right after the other.
Yeah.
Yeah, but keep in mind that these topographical variations actually aren't very high.
Yeah.
This is all pretty flat. What's up?
Do you know the resolution of this image?
Taken a distance of 80,000 miles. 80,000 miles, yeah.
Okay.
So this is...
They didn't give you a per.
No, there wasn't. These are actually pictures directly from Voyager, so they're not annotated or anything, and I'm sorry about that.
Oh.
So,
NASA's.
but Yeah, I mean, you can kind of see more of it here. It does just have that strange texture, and a Triton is a, what is it? Diameter of, what was it again? 1,600 miles. So that might give you a rough scale that these kind of cracks are probably like a couple miles wide.
Oh, it says 600 per pixel in that.
Oh,
So
well, I'm silly. Thank you for pointing that
you.
out.
I didn't see it at first.
Yeah, so if that's helpful. Anything else? Hi, what's up?
What's the eccentricity of Triton? Or
Oh, it's actually almost perfectly circular. That's really strange, considering it's in a retrograde orbit.
it to
It's-
be a captured object?
Yeah, but you would expect it to have a more eccentric orbit if it like were captured, I guess. But no, it's almost perfectly circular. It's actually like slowly spiraling into Neptune. So one day it'll get into the Roche limit, get ripped apart, and now Neptune will have an even bigger ring than it already does, because you can see. And here's Neptune's rings. Hi, what's up?
Is that what gravitationally rounded means, or what does that mean?
Basically, when a body has enough mass, it gets pulled into a sphere. I think the smallest body we know of that does this is, I think it's one of the Uranian moons, but it's like 800 miles or something like that to be in hydrostatic equilibrium. That's the formal term, but I knew no one was going to know what the hell I was talking about if I used that, so I said gravitationally rounded. So yeah, Proteus is nowhere near big enough to be gravitationally rounded. This is the only round moon that Neptune has, and it's a weird one.
I think Mimas is the one you're talking about, it's round, essentially.
Mimas?
Yeah, it's about 400 kilometers across.
Yeah, that's a weird one though, and it's got like these huge ridges you wouldn't really see, and it is really small, yeah, but it's got the Verona Rupes or whatever it's called, that giant cliff on it. That Mimas is interesting, yeah.
I think you're thinking of a different moon.
No, I'm thinking of Miranda. I think I'm thinking of Miranda, yeah. Yeah, there's either way, Proteus and Nereid are below the threshold of when gravity would pull an object into a round shape.
So,
So they're irregularly shaped.
I wanted to ask you about you mentioned it, but I don't think you really talked much about it, was the strange orbit where it's not in the equatorial plane of Neptune.
Yeah, I mentioned it briefly. It might, what about it?
So it's like, I think I got it from one of your slides, of about 23 degrees.
Yeah,
Why do you think that is such an anomaly about, so I'm stretching here, to try to see if you could understand all of it. Why do you think it's so strange not to have a moon in the equatorial plane, and what does that tell us about
it's not strange for a moon, but it is strange for a large moon. Because I think all the Galilean like satellites orbit in the same plane as Jupiter's equator. So it's weird that Triton does this, and it suggests that it came from somewhere else and was not pulled into a regular orbit like some of these little guys were. Irregular moons that are usually captured satellites tend to end up in weird orbits around their new planets. So it's just kind of a little bit more evidence that Triton did not form near Neptune, or that it did form near Neptune and something weird happened to it via gravitational interactions.
It's got to be a very transient thing, because there's an interaction with the excess mass at Neptune's equatorial zone, right? It's got a bulge because it spins so fast. So Triton is seeing this. It's going to have this tidal force on it.
That's pulling it into a
tremendous amount of tidal heat must be going on.
yeah, and that also is more compelling evidence for the subsurface ocean. Yeah.
And it's also limiting the lifetime of that moon around Neptune. So
It's slowly spiraling in. Yeah.
So there's some estimate of when it's going to come in.
I don't remember when they said it was, but it will eventually disintegrate and become a ring around Neptune. Yeah.
So it must be very transient.
Maybe that happened to Saturn too. That's food for thought.
Is that what the ring around Neptune is from now, or?
All the large planets have rings. Usually the material comes from one of their planets. Like one of Jupiter's rings has material that is fed into its ring by Io. Saturn has Phoebe that feeds one of its rings. Yeah, the material comes from planets that comes from moons that orbit around the planet. generally. And actually large ring structures like Saturn's don't last very long. Those rings will probably not be there for much longer, maybe a couple more 100 million years or something, but yeah. This is a photo taken in near infrared for the record, so you can't normally see these rings in visible light. They're very faint. Okay.
Thank you very much.